Okay, functions and trigonometry, final exam review. This is video number 4. Picking up on problem number 23. You need to understand your base functions and your transformation of all your base functions, of all trigonometric functions, sine, cosine, and tangent. All right, so here our base function is sine. Okay, this guy up right here, this coefficient, right, that is going to be a vertical stretch, okay, but we call that our amplitude. The absolute value of this guy, this coefficient, that's going to be your amplitude. The standard period for sine is pi over 2. All right, so what does this 4 do? That's going to be a horizontal shrink. I'm going to take my period, 2 pi, divide it by 4. Okay, I get a new period of pi over 2. Okay, now what about this guy? All right, this could be a positive or a minus. If it's negative, it's going to shift right. If it's positive, it's going to shift left. Just kind of opposite of what you think you would do if you added or subtracted something to your x value. All right, so what do I do to get my phase shift? Well, it is going to be this number divided by this number. Very sort of similar thing in what I do to my period. All right, there's a dividing step in there. Okay, so actually your textbook calls this B, they call this C, so this is what C divided by B. So pi over 2 divided by the 4 gives me pi over 8. The negative side means that it's going to shift to the right. All right, so the answer for 23, it's a phase shift of a positive pi over 8. So I'd actually add pi over 8 to all of my x values in my t-table and my parent functions to get that shift to the right. All right, 24, the exact same thing, except I am dealing with the cosine function. All right, it doesn't have a phase shift. It does have an amplitude of 5. The period, I'm going to take 2 pi and divide it by this coefficient of the x, in this case 1/2. So this then has a new period of pi over 4, or a horizontal stretch of, let me think about this, horizontal stretch of double. Okay? All right, identity proofs. Okay, we want to reduce this guy. And what I need to do, you need to have all of your trigonometric identities memorized or provided for you. All right, sine squared x plus cosine squared x is equal to 1. So I'm able to take this sine squared x plus cosine squared x, and I'm able to get rid of these two terms and substitute it with a 1. This is another one of my identities, my Pythagorean identities. Tan squared plus 1 is simply equal to secant squared x. All right, so that's all we have to do for that. All right, on a problem like this, this is a good problem to apply a conjugate to. Okay, we're given this, and when I have this like single denominator thing, all right, I often think of that as a good place to apply a conjugate. And that's what works best here. So on this one right here, I'm going to multiply top and bottom by the conjugate of the denominator, 1 minus sine x. This is the beauty of a conjugate. When I FOIL it together, I'm always going to get some sort of difference of squares thing. Now in the numerator, generally speaking, you have to distribute. And I didn't distribute this time because I was kind of hoping I wouldn't have to. And I guess I was feeling a little bit lazy. All right, and actually that worked out really well for me because let's go back to this guy right here. Well, if I was to rearrange this equation, I could see that cosine squared x. If I subtract sine squared from each side of the equation, I get 1 minus sine squared x. So I can take this term right here and substitute it with this guy. And that's where I got the cosine x, cosine squared x. Now I can divide these guys, and these guys are going to cross out, and all I'm left with is this negative 1, all right, which I go ahead and distribute. So I can take this negative sign and distribute it, make that negative 1, positive sign. This guy was always hanging out as part of the problem here. Now he becomes involved. These guys go away, and this whole thing simplifies this to sine x. And that's that identity. All right, for the next one, number 27, it's actually a fairly straightforward problem, but it does have something exceptionally tricky to it. All right, I need the equation for this graph. Well, I can quickly see that this is a sine curve. And I go, well, how do I know that? Because it starts right here at 0. I'm kind of lucky. I don't have a phase shift or anything like that. It clearly starts at 0. The sine function starts at 0, so I know it's a sine function. Okay, well, how high does it go? It goes up to 4, and it goes down to 4. All right, so I know it has an amplitude of 4. Now, let's say this thing went down like this way and then started up that way. All right, then I know my amplitude would have been negative 4. It would have given me an x-axis reflection, but I don't have any of that garbage going on. All right, now comes the hard part. Okay, so I know that this is going to be a y equals 4 sine, and then what's in here? This is going to get kind of tricky. Well, one thing I can see it doesn't have a phase shift, but that's okay. But I can see that this does not have a phase of 2 pi, a period of 2 pi. All right, well, it's going to have 2 pi divided by b. b is the coefficient of my variable. So I have to kind of figure out what the period is divided by b, or back calculate b. Well, let's look at what this period is. Well, it's obviously not 2 pi. Okay, it is somewhere between this number and this number. All right, it looks like this graph is done in not quarters but eighths. There's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. So it's somewhere between 5 pi over 8, and this guy would be 6 pi over 8. Somewhere in the middle. Well, I can do a little bit better than that. Let's just, for giggles, let's just call it the middle. Okay, so that's 1/8, 2/8, 3/8, 4/8, 5/8. It's not working. Not eighths, 16ths. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, 10/16, 11/16 is about where that point is. All right, usually I think on most questions you're going to get this crossing over at something a little bit nicer. But it's crossing over at something about a little bit less than 11/16. I'm just going to call it 11/16. All right, so my period is 11/16, which is 2 pi divided by b. When I solve for b, I get 32 divided by 11. And you know what? That is dead-gum close to 3. So we can call that then coefficient 3. Slightly less, yeah, that's going to be right, extremely close, slightly less than 3. All right? So then I can then get that horizontal shrink in there of 3x. And I know what I did here might be a little bit squirrelier to most of you. Usually this point is going to cross someplace nice to where I can read it right off the graph and then set it up like this. Instead of crossing at some sort of weird place, a period of 11 pi over 6, I'm going to have something a little bit nicer. But what it does is it allows me to calculate b, which is my coefficient of my x. And then that gives me my graph. All right, a little rough, but it can be done. All right, we'll pick up on problem number 28 on the next video.